Hello YouTube, as promised, I'm back with the second video in this video tutorial, and in this video tutorial we're gonna be learning what exactly these two softwares that we're gonna be using are, that is MPLAB and Proteus. And also we're gonna be starting off with the very basics of PIC18f4520, and also we're gonna be starting programming in embedded C. And the program that we're going to be looking at today is going to be how to interface an LED with our microcontroller, and also how to interface a switch. Well, given that we have got a lot of ground to cover, so I'm not going to be showing you how to download these two softwares, although I'm half-mindedly thinking that I'm going to be uploading the setups of these two softwares on my Google Drive, and then the link would be given in the description. But it's pretty simple. You can just Google it, and also there are a lot of videos on YouTube that show you how to do this. So pretty much I'm just going to be starting with how to do this in MPLAB, how to program your microcontroller in MPLAB. So when you open your MPLAB, that means this icon. What you get is this is the very first page that you get when you open your MPLAB, and the very first thing that you're gonna have to do is create a new project. So in order to create a new project, you have to go File, New Project, and then Standalone Project, Next, and then here you have to select your device. That means your microcontroller that you're going to be using. Given that we're going to be using PIC18f4520, so you're going to have to hunt for PIC18f4520, and PIC18f4520, it should not be very difficult to find. And where is it? Here we go. PIC18f4520. Make sure you select this microcontroller correctly, because different microcontrollers have different pinouts and whatnot. So given you're not going to be using hardware, you're not going to be implementing this on hardware, you're just going to be simulating it. So you have to select simulator, and then next, and then you have to select your compiler, that is C18 compiler. Yeah, one more thing. When you guys download MPLAB X, you're actually gonna have to download a C18 compiler as well. This does not come with the setup of MPLAB X. You have to download it separately. So I'm just gonna be uploading this on my Google Drive anyway. All the three things: the setup of C18, the setup of microcontroller, and the setup for Proteus. Okay, so select C18 compiler, then next, and then you have to give a valid name to your project. So since we're going to be interfacing LED, so let's give LED, and then press finish. I'm not going to be pressing finish because I already have a project created. I don't want to create a new project. And then that's just about it. When you press finish, new project will be created, and that project will be displayed here. See, the name of my project is actually LED buzzer, excuse me. So it's showing LED buzzer. So inside of this LED buzzer project, you can see that there are a number of folders. So whatever code you're going to be writing, it is known as source code. So that code goes into the source file. So in order to create a C file in the source files folder, you just have to right click on source file, go new, then C main file, then give the name, give an appropriate name for your file. The extension is already C, and then press finish. Also, I'm not going to be doing this because I already have a C file created. And then let's go. So this is the very basic code of how to interface an LED with your microcontroller. I assume that it's going to take a lot of time to just type it while being on the video, because, well, we have limitations in the recording. So I just have this code typed already. I'm just going to be explaining you. So since you guys might be knowing a little bit about C programming, every code needs to have a header file. You have to include certain header files. Header files are actually the files where the definitions of these things, that is like int, for, unsigned, void. The the declaration of these things are given in the header files. So for PIC18f4520, the header file that we're going to be using is P18f4520.h. Now coming to the next line, it's hash pragma config lvp equals to off. Well, I hope you guys are really going through with the theory of microcontrollers as well, because all of this is only going to make sense if you know about the theory. I'm going to be recommending you quite a lot of books based on PIC18f4520. There is Mazidi. I'm going to be putting the PDF links down in the descriptions. So if you read about the theory, you're going to be knowing what exactly LVP is. LVP actually stands for low voltage programming. We don't need it right now, so we have just configured it as off. And then if you have configured watchdog timer, that is WDT, you're going to be knowing what WDT is in the theory. It's actually a timer. Well, I'm not going to be going into too much details. Just let me know if you want me to put another video covering all the theory portion of microcontrollers. I'm gonna be doing that if only you guys ask me to do. So we're not gonna be using watchdog timer as well, so we have just put it off. OSC is nothing but the oscillator. Our microcontroller is gonna be needing clock, so oscillator is gonna be providing it with clock. So oscillator equals HS, that means high speed. Just know that these three would be remaining this way only in whatever code you're going to be writing in the upcoming sections. So this pretty much is the standard way of writing this. Going further in the code, we have void delay. It's just a delay function that I have declared here. It's its declaration and definition. What this delay function is going to be doing, whenever I call this delay function, somewhere in the program, okay, let me think an easy way to explain this. See, what this is going to be doing is, see if there is a certain position or certain state that my microcontroller is functioning in right now, and I want that state to be held for a certain amount of time. So what I'm going to be doing is, after declaring that state, I'm going to be calling this delay function. That means my code will be running in this for loop, in nested for loop, again and again and again and again, as long as this condition goes to false. That means whatever time I want my code to be delayed, that means whatever time I want my current state to be held for, I can put this value as in, say this takes a parameter x, so here I've used delay function, I can put 100. That means for 100 milliseconds the current status of my microcontroller will be held that way. It's gonna get more clear, it's gonna get clearer to you as we go further. So now this is my main function. Now what important about this tris is, okay, let me first explain you what tris is. You have to know that for every PIC18f4520 there are 5 ports. That means port A, port B, port C, port D, and port E. Port A is an 8-bit port, port B is also an 8-bit port, port C is also an 8-bit port, port D is also an 8-bit port, but port E is actually a 4-bit port. I'm gonna be assuming that you guys know what 8-bit port and what 4-bit port is, because, well, let's say if a port is 8-bit port, that means it has 8 pins, and I can transfer parallelly data up to 8-bit. That means a data which is of 8-bit, I can transfer that parallelly. So tris, what this tris does is, tris, they are actually registers. They are actually 8-bit registers. There is a tris A register, tris B, tris C, tris D, tris E. So what happens is, we have to tell our microcontroller that the port that we're using is configured as an output port or as an input port. That means either we're going to be sending data from the microcontroller to the device that has been interfaced with the microcontroller. That would make that very port as output port, because we're sending data out from the microcontroller. And say I've interfaced something that takes data in from the port to the microcontroller, that makes the port as an input port. So we have to tell the microcontroller what sort of port that is. So if I see if there is the port C, talking about the port C, it is an 8-bit port, 8-bit register, sorry, talking about tris C. Tris C is an 8-bit register. If I configure that register with zeros, all zeros, that means it configures that very port as an output port. If I configure it with ones, all ones in the tris C register, that means that very port would be acting as an input port. With zeros, output port; with ones, input port. That means if tris C equals to 0, that means it's going to be acting as output port, and if tris C equals to 1, that means it's going to be acting as an input port. We actually pass values in hexadecimal system. So 0x defines hexadecimal, 0x. And if I were to say pass values in binary, so I'm going to be using 0b. You guys are gonna catch up. Okay, so here I've just defined the port as an output port. That means I'm going to be sending data from my microcontroller to whatever that would be, whatever is it that would be interfaced with the port C. Okay, there is tris and then there is port. Tris is used to configure a port as an output port or input port. This port C is actually used to send data. Either we can send 1 on a port or we can send 0, and we can only, that means it's just we're sending either high voltage or 0. See, given it's an output port, that means we're gonna have to send something from the microcontroller to the device that has been interfaced to that port. So on port C, I am sending 1. That means there is some voltage on that very port. Port C bits.rc0, that means we are not sending 1 on the entire port, we are just using the 0th pin of port C, and I'm sending 1, that means high voltage, on that very pin. That is all. On just that pin I'm sending 1, because I'm going to be connecting LED on that very pin. You're going to be seeing later. So next, what I've done is I've called a delay function, and that delay function I've passed value 100. That means 100 milliseconds. That means I've sent 1 here, and for 100 milliseconds this port C, on port C, it will be high voltage, and after that certain amount of time, that is 100 milliseconds, I've sent 0. That means it's gonna be off. Whatever it's connected, whatever is it that's connected on port C, RC0, it's gonna be on first, and for after 100 milliseconds it's gonna be off, and then for 100 milliseconds it's gonna be off, then again for 100 milliseconds it's gonna be on, then again this goes on and on and on. I don't expect you guys to be understanding the entire thing, but then it's gonna be a lot clearer when we work on Proteus. So here, this is the Proteus software, and this is the very first page that you're going to be getting when you open it. So what you have to use is this ISIS. This is what we are actually interested in. Okay, so this is our ISIS. This is where we do all the simulation work. The first thing that I need here is PIC18f microcontroller. So what we are going to do is right click here, place component from libraries, and here we're going to be writing the name, that is PIC18f4520, and this is the microcontroller that we're looking for. Select it, press OK, click here once, and then you'll get it, and then just place wherever you want to. So the next thing that we need is we need a VCC for this microcontroller, because it needs power to work. So right click again, place, and then you can see terminal. On this terminal you can see power. Just click on power, just place here, and then just connect it to 1. Always remember, VCC or power, it's always connected to the first pin here. Now, as you can see in our code, we are using port C, pin number 1. So I'm gonna be interfacing an LED on port C. As you can see here, it's RC0, that means port C pin 1, RC1 port C pin 2. Like this it goes on. And then what I need an LED, so let's just find an LED. Okay, so just type LED and there are going to be a bunch of LEDs here. Just use down arrow key to go to different LEDs. I'm going to be using a blue LED right here. I'm going to be selecting it and then OK, and then just place it. Oops. Alright, so as we can see, I've interfaced it with pin 1 of port C, that means RC0. Also, what we need is, we need to ground the cathode part of the LED. So just go to place, terminal, ground. Then you have yourselves a ground. Alright, so this is pretty much done, but this is not going to be working now, because see, what you have done is, here you have written the code. You have to compile this code, and after compilation you are going to get a hex file. The output of the compilation would be a hex file, and that hex file is to be loaded here. So first let's compile it. You see, go up here, you can see this little hammer which says clean and build main project. So just click on that, and if there are no errors, you can see your program will be compiled, build successful, and the total time taken to build it is 2 seconds. Now your hex file is created, as you can see, loading code from this, and your hex file is created ledbuzzer.x production.hex. This is your hex file, so you have to load that hex file. So what you have to do is double click on your microcontroller. Yeah, one more thing, the frequency that we are using, the clock frequency that we're going to be using throughout is going to be 12 megahertz. So don't forget to change it. It's going to be 4x4, you have to change it to 12 megahertz. Alright, see, program file, here you have to load your hex file. Click that button, go to the computer, then go to users, then go to this, your whatever your system's name is, then go down, then you're gonna find MPLAB X project. Go to this folder, then choose your project, whatever project you're working on. The name of my project that we're currently working on is LED Buzzer. Double click it, go to dist, go to default, go to production, and this LED Buzzer X production.hex is your hex file. So just select it and open. As you can see, it is loaded. Press OK. Now if you go down on the bottom left corner, you're gonna see this play button. Just press it and your simulation will be started. So as you can see, this LED is glowing. It's glowing and then it's going off. It's turning on and turning off, turning on and turning off. I'm gonna stop this right here. And this is happening because we have first given 1, that means high voltage, that means LED goes on, then we are waiting for 100 milliseconds, and then we're turning it off, and then again we're waiting for 100 milliseconds, and then we are turning it on, and then again the same things goes over and over again. The duration for which it's gonna stay on, you can change it by changing the delay. If I say, instead of 100, if I say 1000, and it's gonna be off for 1000 milliseconds. So just save it, and then whenever you make changes in your code, don't forget to build it again. So here we go, build it. You don't have to include the hex file again and again, just press OK. So you can see the time for which it goes on and it goes off has changed. It is turning on and it is remaining in that very state for a longer period as compared to the last time. So this is pretty much how it works. This is the very basic thing that you can do with your microcontroller. You can change things here, and then the result of that will be seen here. So I hope that you guys understood what TRIS is, the very basic motive behind this video was to make you understand how Trish works and how port C works. Okay, another thing, let's say I change it to RC2, that means the third pin. That means the third pin of port C, and if I build it, as you can see, my code will not work. I mean, this will not work because what I've done is I've programmed the port C pin 3, but I've interfaced my LED to pin 0, so that does not work. So I'm gonna have to interface it to pin RC3, interfacing it with RC3, and if I run it again, oops, I interfaced it with wrong pin. I am so sorry. So as you can see, it's going on and going off, going on and going off. So this is how this thing works. Now I'm gonna be doing a lot more in this. In the next video we're gonna be talking about how to configure a port as an input, and then how to use that input port to take certain things as an input. What we can do is we can interface a switch, because switch is going to be taking input. Microcontroller is going to be taking input from the switch, and based on the functionalities of switch, we can again turn on and turn off the LED. We don't have to give the delay. We can program it stating that as long as the switch is on, the LED should glow. As long as the switch is off, the LED should stop glowing. We are not talking about placing a switch somewhere around here. We're talking about placing a switch somewhere around here. More on that in the next video, and please don't forget to subscribe and like and share. And if you have any queries, just ask in the comments below, and I'd be more than happy to help you. I'll see you in the next video.